Now we're going to talk about systems of inequalities. These are inequalities because they have the greater than or equal to signs here. They don't have to be the same sign. They could be different. The process is the same as systems of equations. We're going to graph it. So we have a negative 2, and then we'll do the rise and the run of 1. Now again, I recommend that you repeat the slope over and over and over again as many times as you can, and it makes your line a little bit straighter. This one is a solid line because the inequality sign is a greater than or equal to sign. The greater than symbol also means that we are going to shade this above. So we're going to color in the entire area above the graph to symbolize that any of the points in the shaded region are going to work with this particular inequality. But it's not just that inequality that we have to worry about. We have to worry about the second one, which starts at positive 1, has a slope of 4 over 1, so up 4 over 1, and down 4 and back 1. It is also a solid line, and this is what the second line looks like. Now we will have a different shading. So for instance, we are going to shade this one greater than, so that is going to be above, which is kind of more towards the left. Now you can see as I shade this in that there's some area that is yellow and some area that is orange because it was already shaded by the pink. So the actual answer to this is the orange area. Any point in the orange area is going to work in both of the equations. The yellow area by itself only will work above the green one. It will fail when you test it above the red one. The pink area by itself will only work above the red one. It'll fail when you test it above the green. There are special cases whenever you're talking about systems of inequalities. For instance, number 3, if you were to graph that, you would start at positive 1, you would go up 2 over 1, and you would repeat that slope over and over again to make your line more accurate. This is a solid line because it's or equal to, and we're going to do the shading just like what we did before. So I'm going to shade this above because it's a greater than or equal to sign. So since it's greater, that's above. Now we're going to do the second line, which is starting at negative 2, and then I do the slope, up 2 over 1. Now you may notice that on the systems of equations one, it would be no solution here, but this is inequalities, and so it's not necessarily no solution. We have to do that by a dotted line because this is not or equal to. When I go to shade this line, you may notice that I start shading above, and this entire area is yellow until I get also above the red line, and that is shaded in as well. And so the actual answer to this is the pink area that we had shaded first. It's the orange now because it was shaded already, and the yellow area didn't really add anything to it. So this is kind of a special case where the second equation doesn't really affect the overall view of this graph. There are several other types of similar situations. If you have two parallel lines, one going up this way, one going down that way, there will be no shaded area at all, so this would be a no solution. If you had two parallel lines, the top one going down and the bottom one coming up, then the area in between is going to get shaded. And any of those points will work in both of the situations. Some of them are going to have to be rearranged. For instance, this one right here, you'll have to rearrange the equations. The first one, you would subtract 2x from both sides, leaving you y is greater than or equal to a negative 2x plus 1, which would start at positive 1, down 2 over 1, and these would be the points along the slope of that line. This is a greater than or equal to, so it is solid, like so. And since it is greater, we're going to shade that above it. Now above is on the right this time because we have a negative slope. It's just the stuff that is on top of the line. So this is the shaded area for the first line. Now the second one, we're going to start off by subtracting x from both sides, and we'd have a negative y is greater than or equal to a a negative x plus 2. Now we can't obviously do this right now because we're going to have to divide by a negative 1 first. And don't forget the same inequality rules that apply with everything else. If you divide by a negative, you have to flip the inequality sign around. Leave me a positive 1x minus 2. Start off at minus 2, slope of 1 over 1, and this is the graph. So this is a solid line because it's an or equal to, and we can just draw that in. We'll then need to shade the area just like what we did before. And when I shade this, I'm going to now be less than. We want to look at the final version in slope-intercept form. We want to be less than that line. And you can see the area where the answer would be is the area of orange there. Any point in that section is going to work in both situations.